Okay, so the case study that we'll model in this exercise is the Musmeci bridge, as you can see here. And it appears to be, it's a very beautiful project, a great example of form finding at an infrastructural scale. We'll model this kind of twisted form. You can see how the concrete has appeared to be almost stretched between its constraining points. Here it's kind of supporting the bridge, and this creates a series of arches basically that are kind of drawn back down to the ground and then up again. Take another look here. So there's an arch here, and in between there's these kind of contact points where the concrete is kind of formed into touching and supporting the bridge, and then back down again. So let's get started. So to get started, I'm going to set my arbitrary but general kind of proportions. I'm also in feet here in Rhino. This may be helpful for you to also follow along in that way. So set up your model for feet. And I'm going to grab a rectangle command over here. Click anywhere on the left of the screen. And I'm going to draw this out to around, let's say, 83 feet by about 12.5 feet in height, something like that. You can go 85, 12, or something similar to those proportions. I went 83 by 12.5 because I tested that dimension and it worked pretty well. Okay, and the next thing I'm going to do is I'm going to start setting up a few points here as reference. So I'm going to grab a point object and I'm going to put that at the midpoint on the top and bottom of that rectangle. And then I'm just going to kind of scale those off a little bit. You don't necessarily have to do that, but I'm going to do it because I want to be able to see where the center of the next step is, because I'm going to count away from that. So let's do that. So let's build a mesh in here. So I'm going to go to mesh primitives, plane like we did before, and take a look at the x count and y count up on my screen. I've got 60 in the x and 10 in the y. Okay, so you should do something similar. And go ahead and click on the bottom left corner all the way up to the bottom right to make the mesh. Okay, and now I'm going to grab a different layer. I'm going to go to my layer 1, which is the red layer, and I'm going to start laying in some points. And these points are going to end up being our contact points for both the ground and for the top part of the bridge. So they're all going to be anchor points. Let me see if I can find the model. Yeah, this thing here. So we're going to end up drawing out the points for the anchors that touch the ground, and then we'll use a similar constraint to lift those points up and to touch up here, and then again down below again. So we're just going to have to kind of plot out those points first, and then we can do the simulation. Okay. So follow along. I've done a little test, and I've gotten a decent proportion out of this. And we're just going to count off from this point here. We're going to count off a few lines, place a point, and keep doing that. So I'm going to, in my red layer, I'm going to just grab the location of, I'm going to grab a point. And I'm going to count out 1, 2, and 3. So on the third line, I'm going to draw a point, and that's basically putting 3 mesh faces in between the center point here and where I want that point. And then I'm going to go 3 again, so 1, 2, 3. And then I'm going to X out of that command. I'm going to grab those 2 points. Actually, yeah, we can do that. We can grab these 2 just to keep it clean. We're just going to copy these points up, directly up, orthogonally up to the top edge there. And then I'm going to go into my blue layer and do the same thing, but I'm going to count out a different spacing. So here I'm going to count out 1, 2, 3, 4, 5, 6, and then 1, 2, 3, 4, 5, 6, and then again 6. So 1, 2, 3, 4, 5, 6. Hopefully that left 1, 2, 3, and 1, 2, 3. Yes. And then I'm going to go back to my red layer again and just put in 2 more points, which is 3 away from that blue one there, and then 1 at the corner, like that. So the pattern is basically 3, 3, 6, 6, 6, 3, 3. You can play around with this configuration later. You'll get slightly different results out of this. And then I'm going to take those points I just drew and copy those up again to the top edge of the mesh. And now what I'd like to do is take all of these and mirror them from that center point over to the other side. So now I've created a symmetrical set of constraint points. Okay, and I'm going to head into Grasshopper here, and I'm going to start drawing these points in. So first I'm going to select those, you know, actually, 1, 2, 3. To make this a little bit easier, I'm actually going to take these, the outermost red ones, and make them blue. Now that I think about it, it's probably a little cleaner that way, because those are going to go up. I'm trying to distinguish between what points go up and what points go down. And in this case, these 4 stay down, these 4 stay down, and these sets, this set of 8, stays up, and that goes up as well. So sorry about that. So now my configuration is 4 red in the middle, 8 blue in between, and then 4 red at the end. And that's true for both sides. Okay. So I can go back into Grasshopper and get started. I'm going to grab first those anchor points. So I'm going to just go to right-click, select multiple points, and just grab those 4 red ones there, and then the red ones on the ends. Okay, so those anchors are in. And I'm just going to call these low points, like that. And I'm going to bring in that other set of points, the blue ones, all of them, and call these the high points. Okay, I'm going to head off into perspective view now. I can turn this to shaded or ghosted, and I'm going to start setting them. I'll set the mesh in, so we're going to grab that mesh parameter, set one mesh, and we can hide that original mesh. We don't need to see that any longer. Okay. All right, so let's go ahead and start setting up our Kangaroo stuff. So we're going to go to K2, grab our bouncy solver. I'm going to make the set of static anchors the low points. So I'm going to grab that anchor component from goals point like that, and I'm going to pop that in. And then I'm going to grab one of these for my mesh, even though I don't need to set that in just yet. I'm also going to go to goals mesh like we did last time and use the edge length component. Mesh goes into the input there. Our length factor is something between 0 and 1, and we can leave the strength as is. Actually, you know what? I'm going to increase the strength to 10. It's better to start something a little bit stronger, I'd say, for this one. So I'm going to increase that to 10 like that. Okay, and I'm going to drop that into Kangaroo. Now something's already going to react, you know that. Before we get any further, let's go ahead and grab those two kind of control inputs, which is the true and false and the resetter. So that's the button. And yep, we can go ahead and turn that off for now. The other thing I'm going to do is like we did last time at the end, but I'll do it now earlier, is go over to set, grab the clean tree, put that in there. Go ahead and turn off that solver so that, or turn off the preview for the solver, you know, so I'm just going to make that true, so that I don't see all those vertices. I just want to see the mesh. Okay, so here's my setup so far. I'm going to grab these, I'm going to move this stuff out of the way because that's done. The high points now we can work with, and this is a slightly different process. I think I showed how to move, when we did the grid shell example, we also showed how to move points in order to get them to push things around on screen. So we're going to do that again. This time we're just going to move them to make our high points that touch the bottom of the bridge. So we're going to still use an anchor component for that, just like the one above. But here we're going to use our translation in order to move them around. So we can go over to intersect, transform, move, and then we got to give this some kind of parameter that we can play with. So I'm going to just double click, type in Z, and then I'm going to put in a slider between 0 and 10. It's good enough for now. and I'll just make that, I don't know, 7 to start. And then we can put the result of that move directly into the T parameter here, which means it'll always update. As I move this thing around, the mesh will react to those new anchors. Okay, and we're pretty much set up here to start seeing things happen, so I can go ahead and add my mesh from the light bulb. And the mesh is the first one out, so I'm going to go over to set, list item, and just kind of break that out to separate it from the lines, because we'll add some resolution to this in just a second. Okay, so go ahead and simulate this. Okay, and it looks like we've got a really good start on it. Pretty simple. Go ahead and play with some of the parameters, maybe drop that, bring that up a little bit further, have a look at the results. And you can see what's happening, right? So the anchors that we left low are forcing the mesh to kind of form this form down below, and then the anchors that we lifted up are stretching it up to form this arch here. This is just a kind of end condition that ends our form finding model, but of course this ends probably differently in reality. But yeah, so we're looking at a pretty good approximation of the structure. You can see how that kind of nice curve is drawn right out through the section, if you will, the longitudinal section right through the center of the form. It's quite smooth. Let's take a look at the other view. It's hard to see really what's happening there. But in the top view, we get a nice symmetrical form finding. You could also play with adding some resolution, either at the beginning or at the end of the script. So for now, let's go to the end. We can head over into Weaverbird, grab the Catmull Clark, and kind of smooth that out a little bit, maybe produce a better drawing. And then we'll right-click on S and click Fixed so that we don't lose our fixed points. And this will give us a little bit more of a smoother, if you will, representation of the exact same form. The other way to do that, so let's turn that one off, turn that one back on. And the other thing we can do is head into Kangaroo, go over to Mesh, and grab this Refine component. And here we can kind of add a little bit of refinement to the original mesh at the beginning of the script. And you can turn that preview off. And then go ahead and replace those two inputs. So now you're seeing that the forces are being put through the mesh slightly differently. So the result is a little smoother, but also a little more exaggerated, if you will. It's a little more stretched, right? We're seeing more curvature between the points. And maybe that's a good thing. So here I really like the way this is looking. And I think this is probably the more appropriate resolution for this kind of thing, for this kind of geometry. You can, again, where is it? There it is down here. You could start adjusting some of these parameters to try to get some different results out of it. And here we're pretty limited within a pretty tight solution space. I mean, we're not going to see much differentiation here because of the anchors. Really the way to adjust this into different forms would be to change the input parameters, right? So move around the anchors or drop some of these anchors at different places or develop a different kind of anchor to mesh relationship. So if you were at a wider mesh or a thinner mesh, a longer mesh, if you were to change the spacing, for example, between the anchors, you would end up with different results. So you're welcome to experiment with that and have some fun with it. But that's really it. This was a short, kind of a short add-on. I just wanted to walk through a couple different case studies. First one, the drone port, and the second, the Musmeci bridge. Yeah, it's quite a beautiful bridge. Take a closer look at it if you'd like. There's some really nice documentation of it. Here's some of the early on form-finding models. So this is a model made out of rubber and rope and metal. A bit different than the way Friado would work. And so there's some really good examples also, or photographs of these huge form-finding models that they built in their lab to test the structure before completing it at full scale. Some really amazing stuff. And this is a plastic model that we looked at earlier that they kind of formed into position as a representation. And here's another image of them kind of hanging weight off of that form-finding model to get a sense of its structural stability and capacity. Okay, that's all for this one.